All right, Chapter 11 review. We're going to work on page 591, 1 through 29 odd on this video. Okay, so 1 through 9 says this: describe each pattern formed and find the next three terms. So number 1 is this: 80, 77, 74, 71, 68. Well, there's a common difference of -3. It's decreasing by 3 every time. So find the next three terms: 65, 62, and 59. Number 3: 0, 3, 7, 12, 18. So when we look at a common difference between the first term and the second term, there's 3. Second term and third term is 4. Third and fourth is 5. Fourth and fifth is 6. So we can assume we're adding 1 every time. So the next three terms, we would add 7 to get 25. We would add 8 to get 33. And then we'd add 9 to get 42. Okay, number 5. They give us 100, 10, 1, 0.1, and 0.01. So we are dividing by 10. Or you could say we're multiplying by 1/10. The next three terms would be 0.001, 0.0001, 01, and then 0.00001. Easy enough. Number 7, moving along. The sequence is 4, -8, +16, -32, and +64. Well, we are multiplying every time by -2. So the next one would be -128. Next one would be +254. And the third one would be -508. Number 9. The pattern looks like this: 0, 1, 0, 1/3, 0, 1/5. Okay, looks like we're alternating between 0 and 1 over the next odd. 0, so those would be the next three terms. Okay, number 9. It says the sequence is this. So that was number 9, sorry. Number 11. A triangle is replaced with 3 triangles. So it says do the first 4 figures. So that'd be figure 1. That'd be figure 2. Figure 3 would look like this. There'd be 3 small triangles to replace that one. 3 small triangles replace that one, and 3 small triangles replace that one. And the fourth one, it's going to get a little crazy. So I got 3 small triangles replace the first one, and 3 small triangles replace the second one. Okay. So I took care of the top box. Now I got to do it again. 3 small triangles. 3 small triangles, 3 small triangles, 3 small triangles, 3 small triangles, and 3 small triangles. So I should have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. I should have 27 small triangles. 13. Write a recursive formula and then find the next term. So recursive means it has to include the previous term. So the order goes 43, 49, 39, 37, 35. So the common difference is -2. So the a sub n would be a n minus 1, the previous term, minus 2. The next sequence, or the next one, would be 33. All right, 15. The order looks like this: 6, 1, -4, -9. It looks like we're subtracting 5 every time, so I could say that a of n equals the an minus 1 minus 5. The next term, -9 minus 5, would be -14. 17. So it goes 1/2 times 1/4 times 1/8 times 1/16 times 1/32. So the recursive formula for this one would be a sub n equals 1/2 times a of n minus 1. The next term would be 1, 2, 3, 4, 1, 2, 3, 4, 5. The a of 5 would be 1/64. Okay. 19. Write the explicit formula for each sequence and then find a of 12. So 19 says this: 1/2, 1/3, 1/4, 1/5, 1/6. Okay, so a sub n is going to be 1/1 plus n. Then it says find the a of 12. The a of 12 would be 1/13. Okay. 21. Write an explicit formula and then find a of 12. Here's the order: 3, 7, 11, 15, 19. Well, the common difference is 4. My a of 1 is 3. So my explicit formula is a of n equals a of 1 plus d times n minus 1. Okay. So a of n equals 3 plus 4 times n minus 1. So I can distribute the 4, so it's going to be a of n equals 3 plus 4n minus 4. So a of n is just going to equal 4n minus 1. Alright, so find the 12th term. So the a of 12 would be 4 times 12 minus 1. So the a of 12 would be 48 minus 1, which would be 47. Okay, 23. Alright, 23. The order is this: 2, 5, 10, 17, 26. So our common differences here would be 3, 5, 7, 9. And then now we can take the second level and see if there's a common difference. And we find out there's a 2. Okay? But let's just inspect this really quick as well. So when a1 equals 2, a2 equals 5. Well, what if, is that the same thing as n squared plus 1? It sure is, isn't it? So a1 equals n squared plus 1. And then it says find a of 12. Well, the a of 12 would be 12 squared plus 1. So the a of 12 would be 144 plus 1, which would be 145. Okay. That's a tough one. Now, we could have went in and did some matrix work and set up a matrices to solve that one. 25. Decide whether each formula is explicit or recursive. So a of n equals 1/2 n times n minus 1. Well, since I don't have an a n minus 1, okay, it's got to be explicit. So we need to find the a of 1, 2, 3, 4, 5. So when n equals 1, it is 0. When n equals 2, it's going to be 1. And when n equals 3, it's going to be 3. And when n equals 4, it's going to be 6. And when n equals 5, it's going to be 10. Okay, I'll just kind of show you the work quick. So that would have been 1/2 times 2 times 1. That would have been 1/2 times 3 times 2. That would have been 1/2 4 times 3. That would have been 1/2 5 times 4. Okay. 27. A of n equals -3 times a of n minus 1. A of 1 equals -2. Well, that's recursive because it has the a n minus 1 in the equation. So a1, 2, a3, a4, a5. They spotted us a1 at -2. So when we plug in that, okay, so the a of 2 is going to be -3 times -2, which would be 6. So a of 3 is going to be 6 times -3. So it's going to be -18. A of 4 is going to be -18 times 3. So that's going to be 54. And A5 is going to be -162. Pretty easy. 29. Okay, A of n equals 2n squared plus 1. Well, that's explicit. And then find the first 5 terms. So we got a of 1, a of 2, a of 3, a of 4, a of 5. So a of 1 is going to be 2 times 1 squared plus 1, which would be 3. A of 2 would be 2 times 2 squared plus 1. So that'd be 9. A3 would be 2 times 3 squared plus 1. So that's 9, 18, 19. A4 would be 2 times 4 squared plus 1. Would be 33. And a of 5 would be 2 times 5 squared plus 1. So that'd be 51. Okay, that's it for the first part of lesson 11.1 for the review.